Now that you know how to do the positives, let's figure out how to get the maximum number of negative roots that are possible using Descartes' rule of signs again. Now, the official way of doing this is to substitute a negative x for every x that you see. Do the arithmetic that results, then count the number of sign changes that you have, and you can do a subtracting of 2 just like we did with the number of positive roots. Let's see it in action and see if we can't figure out an easier way for us to get this. As I substitute a negative x for each of the x's, it occurs to me that the only things that will actually change sign are the ones that have odd exponents. So each thing with an odd exponent will need to change its sign, but the ones that have an even exponent will stay just like they were. Let's go through and see what happens. Now, the coefficients themselves won't matter. All we care about is just the signs. Looking at the first term, it's got an odd exponent, so this one's going to change from a positive to a negative. The thing that we had here is our second term. It has an even exponent, so it's not going to be changing any as we substitute that negative x. It was negative, it'll stay negative. Our next term has an odd exponent, so it's another one that'll need to change. It was a positive, now it's going to be a negative. The next term, even exponent, since it's even, it'll stay just like it was. Our next term has an odd exponent. Remember, this is an understood 1 that we have right here. So since this one is odd, it'll change from a negative to a positive. Our constant value will stay just like it is. The only things that had to switch as we substituted negative x for all the x's were just the things that had an odd exponent. Now let's go through and count our changes in sign. We started with a negative, it stayed negative, it's still negative. Here's our first change in sign, and in fact that's our only change in sign. This tells us by Descartes' rule of signs that this particular polynomial will have exactly one negative solution. You can't subtract 2 off of that without getting below 0, so no need for us to worry about subtracting. The maximum number of negative zeros or solutions comes from the sign changes after we've substituted a negative x for every x. Now, just like before, if you're able to subtract 2, keep subtracting 2 until you can't anymore.